Good morning, students. In this video, we are going to discuss about the second mechanism, hardware mechanism called as interrupt. For the synchronization purpose, we are going to see about the interrupt. What actually an interrupt? Here, the I/O device initiates the action instead of the processor. The I/O device sends an interrupt request signal over the bus whenever it is ready for a data transfer operation. As like this required synchronization is going to be done between the processor and the I/O devices. Let us see about this one. In a program controlled I/O, when the processor continuously monitors the status of the device, it does not perform any useful task. Here what happens, an alternate approach would be there for I/O device to alert the processor when it becomes ready. By sending an hardware signal called as interrupt to the processor, the interrupt request line is dedicated for this purpose, so the processor can perform some other useful task while it is waiting for the device to be get ready over here. So here, what is the need for interrupt? The operating system is a reactive program. When you give some input signal, it will perform a computations and produces an output. But meanwhile, you can interact with the system by interrupting the running process, or you can stop and start another process. So for this purpose, we need the interrupt. As well as this reactiveness is due to the interrupt is going to be made. So modern computer systems are interrupt driven. Okay, so that what happens, the interrupt I/O devices initiates the action instead of the processor, so that the I/O device sends an INTR signal over the bus whenever it is going to be ready for the data transfer operation. So like this, what happened, the required synchronization is going to be done between the processor and the I/O devices. Let us see about how it's going to get performed. An interrupt, there are many situations where other tasks can be performed while waiting for an I/O device to become ready. A hardware signal called an interrupt signal will alert the processor when I/O device become ready. The input signal is sent to the interrupt request line. So this is the input signal is going to be called as the interrupt signal, which have been sent to the interrupt line, request line, so that the processor can be performing its own task without the need of continuously checking the I/O device. So that the waiting time is going to be get overcome by this particular interrupt process. So that the routine, the interrupt service routine can executed its response to an interrupt request line that is going to be called as interrupt request routine. So the processor must inform the device that a request has been recognized by sending an interrupt acknowledge signal, INTA bar. So this INTA signal, which is going to be called as an interrupt acknowledge. So for example, we will take in one small program that is going to be called as, which consider a computer and a printer routine. So the figure which is going to be shown over here, which is going to explain about the particular process. So a program 1 is nothing but a computer routine which consisting of an instruction from 1 to m instruction lines are going to get presented over there. Whenever the interrupt occurs, so here in this diagram you're going to see about the interrupt is going to be get occurred when the ith instruction is going to be get executing. So during that time, what happens, the interrupt service routine is going to be get exist over there, and it's going to take the control of this processor, and it's going to execute the remaining and coming back to the main program. Let us see how it's going to be get processed. The processor first completes the instructions up to I instruction. Then the processor loads the program counter with the address of the first line or first instruction of the ISR. After the execution of the ISR, the processor has to come back to the instruction I plus 1. Instruction I plus 1. So therefore, an interrupt occurs. The current content of the program counter is put into the temporary storage location. A return at the end of ISR reloads the program counter from the temporary location or a storage location. This causes the execution of the instruction I plus 1. When the processor is handling an interrupts, it must inform the device that its request has been recognized. This may be accomplished by sending an INTA signal, interrupt acknowledge signal. The task of saving and restoring the information can be done automatically by the processor. So the processor saves only the content of program counter and status register. So saving a register also increases the interrupt latency. Let us see about how the interrupt latency is going to be dealt over there. The interrupt latency is nothing but a delay between the time an interrupt request is received and the start of execution of the interrupt service routine. Generally, the long interrupt latency is unacceptable over here. So that in order to reduce the interrupt latency, most processors saves only the minimal amount of information. The minimal amount of information includes program counter and process status register too. Let us see how the interrupt routine is going to be similar to that of a subroutine. However, there are significant differences. A subroutine performs a task that is required by a calling program. The interrupt service routine may not have anything in common with the program in its interrupts. So, interrupt service routine and the program that it interrupts may belong to a different user. As a result, before branching to the interrupt service routine, not only the program counter but the other information such as condition code flags and the processor register used by both the interrupt program and the interrupt service routine must be stored. This will enable the interrupted program to resume execution upon return from the interrupt service routine. Here, the processor how is executing the instruction located at address I when an interrupt occurs. The routine executed its response to an interrupt request line with the ISR. When an interrupt occurs, control must be transferred to the interrupt service routine. But before transferring the control, the current content of the PC, which is going to be loaded with I plus 1, must be saved in a known location. This will enable the return from interrupt instruction to resume the execution at I plus 1. That is, return address or the content of the PC are usually stored in the program stack. As like that, saving and restoring information can be done automatically by the processor or explicitly by programming instructions. So saving and restoring, how it has increased the interrupt latency such a way, what happened, an additional information that must be saved but be saved explicitly by the program instruction at the beginning of the interrupt service routine. When a processor receives an interrupt request, it must branch to the interrupt service routine and it's going to restore the values. It must also inform the device that it has been recognized the interrupt request. This can be accomplished in two ways. One is some processor have an explicit interrupt acknowledge control signal for this purpose. In other cases, the data transfer takes place between the device and the processor can be used to inform the device. The interrupt request execution of the program may alter the intent sequence of events. Sometimes what happens, such alternation may be undesirable and must not be allowed. For example, the processor may not want to be interrupted by the same device while executing its interrupt service routine. Such a way it's going to begin done over there. So the processor decides provide generally provides the ability to enable or disable such interrupt as desired. Let us see about that in the next slide. So in generally, how we can differentiate the subroutine and interrupt service routine, which is going to be present like this. So a subroutine which can perform a function required by the program from which it is called, whereas the ISR may not have anything in common with the program being executed at the time INTR is going to be received. Whereas the subroutine is just a linkage of two or more functions related to each other, whereas the interrupt transfers a mechanism for coordinating this IO. This is a major difference between the ISR and the subroutine. Let us discuss about the second one called as interrupt hardware. How the hardware is going to be get installed to overcome this particular synchronization problem and